Welcome to the Kielder Observatory podcast, and our first one of 2022. January moving into February, and there's loads to see in the night sky. And another addition to the landscape at Kielder Observatory as well. We'll hear from Dr Laurence Blacketer of NORS, Northern Space and Security, who are behind the project, and we'll find out exactly what's going on in their little shed that has appeared up on the hillside at Kielder Observatory over the past few weeks, and what it means for us here on Earth.
Well, if a collision like this does happen, then, if these two objects hit each other at 10,000 kilometers per second or more, the result is hundreds or thousands or tens of thousands of fragments that can go on and hit other satellites.
First, though, going to speak with Director of Astronomy at Kielder Observatory, Dan Pye, who is back with us once again to talk us through what's been happening at Kielder and what is coming up, and also what's going on generally in the night sky and space issues that you might have read about in the papers, and why you shouldn't be so concerned by everything that you read. Welcome, Dan.
Hello.
Welcome along. Well, lots to get through then. Space junk to come, but first, let's have a look at what's been happening across the last few weeks. And one thing I have noticed, both on the news feeds of Kielder Observatory, people posting pictures from all across the northeast and elsewhere, in fact, is the aurora borealis, which has been in full flow, really, the last few weeks or so. Is it unusual to see it at this time of year, and is it a bit of a surprise to see it?
Yeah, it's kicking Reet off at the moment. I think it was last Friday was really active, and I was devastated because I was at work at the observatory and it was cloudy, and here at my house it was clear and there was aurora visible, and people were taking loads of pictures, and I was very vexed. However, yes, it was visible across much of Northumberland, much of the north of England, much of Scotland as well. And there was a big increase in activity last week. Over the last week, it's been I don't want to say abnormally active, but there's been some reasons behind it, and some of those have been your classical kind of reasons, such as coronal mass ejections, which are ejecting material towards us. Some of them have been as a result of another mechanism. We don't talk very frequently about something called a co-rotational interacting region, whereby the density streams change in the solar wind, which is the artificial, almost like pressures which push away from the sun and carry material out into the rest of the solar system. And the interaction between these two density regions creates almost like a bow shock. Think of it like a big shock wave that you would see here on Earth, like that volcano that went off. Now, that big shockwave can sometimes trigger aurora here on Earth if it breaks through our magnetic field. So that's what was causing some disturbance last week. And it is ramping up more in activity. We're seeing more sunspots. The more sunspots that we see, sunspots are like the cap on your soda can of aurora juice. Once those sunspots are open, out it spills and comes flying into the rest of the solar system. So the more of those we get, the more chance we have of getting aurora. Of course, aurora does happen all of the time here on Earth. It's usually a very active thing. It's just that we're at lower latitudes, so it needs a much stronger display to push further down our planet. And we're seeing more of that as the sun increases in activity. Always see an increase in aurora activity when we start to crest towards the solar maximum, and we're starting to ramp up to that now. So the closer we get to 2025, the more activity hopefully we'll start to see as the months progress. That being said, sorry. Yeah. That being said, there's also another reason, I guess, which is we were coming out of the equinox, and the equinoxes are always a time of year whereby we see an increase in activity as well.
And 2025, then, that's when we're at this solar maximum, and as a result, we should be in a great position for anybody who's an aurora hunter to be getting out there and seeing some great results, all being well.
Yeah, that would be the case, certainly. And I think that's the case for much of the country as well. I think nobody in the south should be disheartened that they can't see aurora down there. It's just that you need the right conditions in order to be able to see the aurora down there. A few weeks ago, it was photographed outside of North Devon. Now, that's pretty south. Even by our northeastern standards, that's really south. So seeing it all the way across the country isn't abnormal. You just need to have the right information at the right time in order to be able to see it, because it's such a subtle phenomena. Sometimes you can see it and not realise that's what you're looking at. It might just look like lights dancing in the sky. It's monochromatic sometimes when you see it. You don't always get these beautiful, vibrant colours. The social media has almost teased us into this false sense of what they look like. They're not as vivid as what they appear in photographs, but nevertheless, that doesn't take away the fact that they're a beautiful thing to see.
So keep your eye out then. They can arrive at very short notice. Now, there are apps, aren't there, that you can get, and anybody who's been to the Aurora Nights that you have at Kielder will be fully aware of all the different tips that and tricks that you can do to give yourself a better chance of seeing an aurora show. But just a few quick tips then for anybody who wants to have a better chance of seeing an aurora display. What would you recommend?
I think you should download an app called Aurora Watch UK. Aurora Watch UK is great because it sends you a notification every time there's some aurora potentially imminent for the UK. And the reason being is because it's connected to magnetometers, which is what we use to measure aurora activity or detect aurora activity, that are more relevant to the UK's locations. So once that's triggered, it sends a little notification to everybody and says, "Ooh, aurora could be happening right now." And then after that, the only thing I will say about that app is, though, it has had a couple of false triggers, one of which was related to a lawnmower. but it's still a good place to go. So when you start with that, you get your notification. The next place that I would recommend that you go is a place called Glendale Sky Auroras. Now, when you go to that website, and you can download you can save a little app to your phone as well. That'll give you a little bit more information, a little bit more depth on what's actually taking place right now. There's lots of numbers on there, which looks quite intimidating at first, and you can learn about those if you want to, or you can just ignore those and go for the map, which shows you spotting locations. So hundreds of people across the UK use it. Thousands of people across the UK probably now use it. And if they have seen some aurora on the back of their camera, they'll put a little thumbs up. And there's enough of the UK covered now for you to get a real comprehensive view as to whether or not you can see aurora at any given moment. So head to that, see if someone near you's seen some aurora. If they have, great, get outside, do some observing, see if you can see it yourself. But you're going to need a camera in order to really verify that it is aurora and not light pollution, of course.
Yeah, I'm just looking at the Glendale Sky Aurora app. And it's totally free, but it's used by authentic and accurate aurora hunters who basically report what they've seen and gives you a chance of whether you're in with a half a chance of seeing the aurora or not. And people are obviously reporting if it's cloudy, so you know which side of the country potentially to head to, and all that. So that's a good little thing to have up your sleeve. But hey, keep trying. I've been trying to see the aurora since for about 9 years now, and I still have never seen it. So we keep going, don't we? We keep going.
We do. I've only seen it once in the past. Well, actually, no. I've seen it twice probably in the past 10 years, I think. Once by accident and not really realising that it was aurora. So and actually the third time was it wasn't visible to the naked eye, but I could see it on the back of the camera.
Yes, yeah, and a camera, of course, will give you a much more impressive view of what's going on than your naked eye. But it's all these tools, and of course, aurora sessions are regularly happening, aren't they? At Kielder Observatory. That doesn't mean that you're going to have a guaranteed sighting of the aurora. Otherwise, Dan would have seen it hundreds of times by now, and not a few. But that session, the aurora sessions at Kielder Observatory, are there to give you an understanding of how to look for it, what it is that you're looking at, and all the tips and tricks you might need to be able to get a good photo of it and a good view of it.
And it's our most popular event, actually, is the Aurora event, because, of course, it's on everybody's bucket list. Everybody wants to learn about it. And interestingly as well, I always ask the question when we do these events, just to see if people have seen the Aurora. And I'm always very surprised at how many people have. Last night, in fact, was Aurora night, and 80% of the audience had seen the Aurora. But the thing is, they didn't know what it was. They'd seen it in places like Iceland and Finland, and some people had seen it in the UK as well, but they just didn't realise what it was that they were looking at. And so they'd come to learn a little bit more about that, and to also learn about how they can increase their chances to see it as well. So it's a great event for filling in the gaps on what it is, and it is a really interesting topic. It's the Aurora as well.
Let's move on to looking at what's actually happening in the night sky then at this moment in time, the end of January into the first few weeks of February. What sort of things are going on that people will be able to see from their gardens, from the Dark Sky Park, from the observatory, or indeed anywhere?
So end of January into February is quite quiet, actually. We've just got the usual full moons and new moon scenario, really. The biggest thing to talk about in February is that Mercury is going to be at its greatest western elongation, which means that it's going to be the biggest distance from the sun and visible, hopefully, to the naked eye in the morning sky. So early in the morning, just before sunrise, you see a little bit of Mercury poking out just before sun comes up, which will be nice. That's the big exciting thing to talk about over the next couple of months. But this time of year is a relatively quiet time of year. No major meteor showers or anything like that.
We do have the planets, though. They do remain around us. You mentioned Mercury, but also Venus will be visible as well, particularly if you're a bit of an early riser.
Yeah, it is. Venus is going to be very close to Mars. So two great planets to see. Venus is very, very bright and Mars is very, very red. So it should look quite nice through a smaller telescope, because there's going to be a bit of a separation between them, or a pair of binoculars might be best to see this with. They are quite small planets, so you'll see them as fuzzy dots, really, even with a great deal of magnification. But yes, Venus and Mars visible in the same patch. Venus actually at the moment is going to be an interesting shape. I think at that time we'll be starting to see it crescent a little bit more, because at the moment there's only a very, very slim slither visible to its left-hand limb. So as we get through into the latter part of February, we'll start to see more like a little crescent moon shape, which is what I love about Venus, because it's the only real planet that we get to see doing that. Is creating this same effect that we get with the moon.
And if you've got a pair of binoculars or a telescope, then Uranus also is going to be visible as well.
Yeah, Uranus is. I love Uranus, because it's an interesting planet to show people, because it's an interesting planet in itself. It's got some interesting characteristics. Of course, it is orbiting the sun, rolling around the sun on its side. Its magnetic field is all messed up. But what I love about it is when you see Uranus, it's as disappointing as what people kind of assume it to be. And I always liken it to the missions which passed by Uranus. When we first looked at Uranus, we saw a turquoise dot. And then a space satellite took an image of Uranus and it was a turquoise dot. And we were like, oh, that's interesting. I wonder if it's got any greater definition. And then one of the Voyager missions drifted by it, took a really high resolution image of Uranus, and it was a big beige dot. So featureless, completely featureless almost. So it's a really curious, interesting world is Uranus. And yeah, you'll be able to see it with a pair of binoculars. It is quite dim, even with a pair of binoculars, and quite difficult to spot amongst the great deal of other stars that you'll be able to see. But you should hopefully be able to see it as just it's hard to explain, because it's not bright and twinkly like stars are. It's more a fuzzy little dot which appears a little bit more stable, and it does definitely have a turquoise colour to it as well.
So there's a few things to look out for. Now, our monthly feature, Pie in the Sky, offers you a little bit more of a challenge. There's something to look out for that maybe is requires a little bit of searching at the very least. Maybe it will require some binoculars. Maybe it will require a telescope. There's just no way of knowing exactly what we'll need until we find out what that Pie in the Sky challenge is for this month. But let's go over to Dan Pie with his Pie in the Sky challenge.
It needs a theme tune. Does this?
It does, rather. But it's just the royalties that we have to pay that's the problem. We're both voiceover artists. Maybe we could do a voiceover for it. And now, ladies and gentlemen, please welcome In the Sky, Pie in the Sky.
Ta-da!
Yeah,
Here we are.
That'll be 25 quid.
25 quid, yeah.
Okay, over to you.
So I think for this month, let's go with some classics, some of the objects which is a very popular topic for astronomers. A very popular target for astronomers, and which is popping into the sky this month, or rising into the sky a little bit higher this month, as towards the end of it anyway. In the constellation of Leo, just towards the back end, almost like it's pooping it out, is our Leo triplet. So Leo triplet is 3 galaxies, which are all wonderful to look at with a nice telescope. Really, really beautiful to see. If you pop Leo triplet into your star searching software, whatever you use, Starwalk or Stellarium, you'll be able to find it, and you're going to need to probably use that to locate this, just because it's a bit more of a tricky object to find. But Leo triplet, beautiful to look at through a telescope. Some galaxies. Galaxy season we're into now. Spring is definitely galaxy season. And you know what? Next month, I might even share with you my favourite galaxy, because it might just be in the right spot to take a look.
Wow. Well, there's a hook and a tease for next month, if ever there was one. Before we finish off and chat with our guest in this episode, who's Laurence Blacketer of NORS, talking about that new installation at Kielder Observatory. I look ahead to what's coming up at the observatory. Now, many of the sessions are currently sold out for the next few months. But there is always the chance of cancellations in the self-isolation world that we live in, and things can change, and so therefore keep an eye out on the social media situation. Is the watchword, yeah? Yep,
definitely so. Yep, always got cancellations coming in because of isolations. Of course, that depends on what changes with any government advice. Our restrictions will be remaining very similar to what they were pre-Plan B, which is still mandatory face masks. Regardless of what the government say, it will be mandatory on site unless you're exempt. And social distancing will still be in place as well. So we're operating exactly the same as we were previously until we deem it safe to completely relax everything.
Okay, and as I touched on, actually, many of the sessions are booked over the next few months, but May, June, July, August onwards, there's plenty of choice there, so plan ahead for your summer breaks. And we do have space, if we do have any space over the coming weeks and months, it's for the kids' events which are taking place. Just talk us through some of the kids' events that you do have on and the differences between them, Dan.
Yeah, so Young Explorers is a very quick event. So in that event, we just a quick introduction to the observatory, whiz you around the observatory in tours. So it's almost like a little taster event. And if we can do some observing during that event, then we can. So there's no strict activity associated with that one. Whereas with Space Kids, there's more activities to do during those events, and they're generally around specific topics. For example, with Space Kids rockets, we're building rockets and launching rockets at the end of the event. With the aliens one, searching for aliens, we're looking at light and how light can tell us a little bit more about these things that we call exoplanets, which are planets around other stars, and whether or not alien life can be on there. And we're actually working on some really interesting workshops with that as well, with that in mind. And that event, I think, will change over the course of the year. And Solar Quest, where the Solar Quest actually is all about the sun. So these events are put on when the sun is out, and hopefully we'll be able to see the sun using our big telescopes. But failing that, we now have another way of looking at the sun as well, because we have our big radio antenna, which can also look at the sun. And there's some interesting little experiments that we're looking at with regards to that, which hopefully we'll be able to get in motion by the time those events roll around when we get into the spring and summer season.
And of course, you can keep in touch with everything that's happening at Kielder Observatory and book your sessions at kielderobservatory.org. You're listening to the Kielder Observatory podcast. Don't forget, if you are enjoying listening, make sure you're subscribing to the podcast so you get new episodes straight to your device as soon as they're released. And give us a review as well if you've enjoyed listening, because that helps other people find us on whichever app you use. It'll be fantastic to hear from you. Next on the Kielder Observatory podcast, we're going to give you a little bit of an insight into a new piece of equipment that is visible on the hillside at Kielder Observatory. And its mission is space junk. There's a lot of it in the night sky, as you're going to hear. Before we hear from Dr Laurence Blacketer, who's one of the people involved in the project, let's hear from Director of Astronomy Dan Pye on this collaboration with an organisation called Northern Space and Security, who are behind this project and what it is that they're doing in that shed.
Yes, so we joined partnership with NORS a couple of years ago now, and the proposal was to create a little shed in which to house some equipment which will be able to image the sky and tell us more about orbital space debris and low Earth orbiting satellites and the trajectories of such. In order to be able to understand whether collisions may take place and just to keep an eye on all of this stuff that's above our head, because of course there's thousands and thousands of bits of stuff up there.
Well, let's find out more about space junk right now with somebody who knows quite a lot about it. Dr Laurence Blacketer is a senior scientist at Northern Space and Security Limited based in Durham, and he joins us right now on the Kielder Observatory podcast. Welcome, Dr Laurence.
Thank you. Pleasure to be here.
Well, first of all, just give us an overview for people who don't know who you are, because it does sound like a very sci-fi agency, NORS. But what is it that you actually are doing, and in real terms, what is your mission?
Yeah, so we're a space situational awareness company. So our objective is, in a nutshell, to improve our understanding of what's going on up there and to provide that understanding to our customers.
As we casually glance into the night sky, we don't see the sheer amount of stuff that there is up there, because it's not only active satellites, but there's other junk, stuff that's come off of spaceships, retired satellites, engines, rocket boosters, all this kind of stuff floating around. And you say there's 500,000 pieces of space junk above our planet at this moment in time. And of course, you're there to help out the people that have got equipment in space to make sure they avoid all of this.
Exactly. So, you go back a few years and the sort of ethos that space is big was very much the dominant mindset. So you can, just leave your satellite where it was and not have to worry about it after it's dead, or the rocket that you used to get there, you can just forget about it. But, decades of doing this has left us in this position where, well, actually there is a possibility we might hit this stuff. So part of the situational awareness that I was talking about that we provide is protection to people's satellites, telling them what's around them and making sure they don't run into it.
So we've got a mixture around our planet of the satellites that should be there and are doing work for us, and then there's all this junk floating around as well, which is sort of a law unto itself, and that's what you're watching out for and trying to spot any problems before they happen. We probably don't realise how reliant we actually are on satellites, do we? Of course, we know it for TV. Our mobile phones communicate with them for sat-nav, but it would really affect life on Earth, wouldn't it, if one of these key satellites was knocked out?
So you've already hit one of the main nails, which is, well, if we're unlucky enough for one of our really important satellites to get hit, then that's a capability or a service that is just no longer available to us. Fortunately, the statistics are such that is an unlikely situation. It may be not impossible that an important satellite gets hit, but maybe it's someone else's satellite, or maybe it's a satellite that doesn't provide a service that is sort of crucial to your day-to-day life. The main issue is Well, if a collision like this does happen, then, if these two objects hit each other at 10,000 kilometers per second or more, the result is hundreds or thousands or tens of thousands of fragments that can go on and hit other satellites. So over the course of potentially decades, this can result in the situation just getting worse and potentially getting out of our control. So there's the short-term protection aspect, and then there's the longer-term environmental aspects of ensuring that space is a sustainable resource that is available to not just us, but our children and our children's children.
Tell us about the installation at Kielder Observatory then now, which is contributing to your knowledge of what's going on in space. And there's a fairly innocent-looking shed that's now been erected up there with alongside the observatories and on the hillside. But what's going on in that shed?
Go back in time and observing objects and tracking their orbits was something that was almost out of reach of small companies or the average person. It was typically done by militaries and governments with radars that cost them millions or maybe even billions of dollars, because it typically is the states that do this in the past to build. These days, as I'm sure you're aware, optical hardware is becoming more and more accessible to, smaller companies and the general public. So we can get what is good quality optical hardware, lenses, cameras, and we can use those to track objects that typically, go back a few years, it would have been basically cost prohibitive to have done that. Obviously, a single site with maybe just a few cameras in it may not perform as well as a multi-billion-dollar radar. If not for any other reason, well, radars operate during the day as well. So there's a bit of a difference there, but the advantage is, well, we can deploy loads of these things. Kielder's just the first one. We can put these things all around the world. And at that point, we can start actually building up a picture of what's going on up there, which is really useful and not seen before. So Kielder, our Kielder LOCI system that will be providing useful and usable information and tracking information will only get better as we build this network of global sensors.
And you mentioned that the equipment, the system is called LOCI. What does it do? How does it work? How is it keeping an eye on what's happening in space at this moment?
Observant viewers out there may notice a connection between LOCI and NORS. So LOCI is our low Earth optical camera installation. And it's a series of, so we've got 4 cameras in total. 3 of them are focused on looking at the stuff that's close to us, so up to maybe 1,000 kilometers. And then there's a 4th camera which is staring at the geostationary belt, so up to 42,000 kilometers away. But primarily, to begin with, we're focused on the stuff that's close to us. So we've got almost full sky coverage. We've got 1 camera pointing south, we've got another camera pointing north, and 1 sort of covering the gap in between. There's no fancy, expensive mount that's required. It just gets to stare in one direction. And as I'm sure many astronomers are aware, satellites can sometimes go through your image and cause a streak as it goes through, which may make you pull your hair out, but that's exactly what we're looking for. From that, we can extract what its position is and get tracking information from that. Dan, you're Director of Astronomy at Kielder Observatory, of course. And as I mentioned at the start, it is a question that's often asked and surprises many visitors, doesn't it, about how much stuff there is in the night sky. And for Kielder to be able to play such a part in giving a great view of the night sky
to this service has got to be a great link for you.
Yeah, it has, and it is a very topical thing that we get asked quite regularly. Particularly, it's an interesting question actually, because people do worry about it, and I don't think they know why they're worried about it, but they are worried about it. They're worried about the stuff that's above our head. I think the concern is that it's going to come crashing down at one point, or if we decide to leave this planet, is it going to have an impact on us leaving this planet and such? So those questions are very common questions that we get asked at the observatory. And I think when we look at these objects just with the naked eye, it's always a shock to guests just how many there is. And when you see one drifting over once every few seconds on some occasions during the summertime in particular, when the sun's really catching these things, we're always shocked at just how many satellites are drifting around and bits of space debris are drifting around. So it's great for us to also communicate with the public and to utilise the stuff that the guys learn from Loki, to embed that into our communications package and talk to the public more about this space debris and what we can do in terms of mapping the space debris and what we can do in terms of mitigating any potential hazards and collisions and stuff as well, just to give them a little bit of comfort, if nothing else, I think.
Dr. Laurence, what have you discovered so far? I know it's fairly early days in you having this installation at Kielder, and you said it's your first one in the world, but hopefully the first of many. But what have you learnt so far from this project?
Well, we've already got some really interesting data. So part of what we're particularly interested in is not just tracking these objects, but also trying to characterize them. So we can have a look at their varying brightness signals as they transition across the sky and make determinations of properties of that object that are particularly interesting. So there was a particular satellite that we observed that has a rotating antenna, and we can see this in the periodicity of the brightness variations, which is very useful information for understanding how that system is operating. And I guess from the other side of the coin, there's also difficulties in running an observatory in a remote location and autonomously as well. So it can be very handy when something goes wrong to be there in order to take the dust cover off the lens that you forgot before you left, or something along those lines. So there's definitely, it's been a bit of a learning curve in how we run a system that we can't touch. And that's been, I guess, one of the challenges and one of the most interesting parts of the project.
And you mentioned that Kielder is the first. Where are you looking to expand this network next across the country? Yeah,
we're definitely in the process of doing that. So we're looking at some other locations around the UK as we're still in sort of the initiation phase. And then it's around the world after that. So in particular, South Africa, New Zealand, places that give us a good geographical distribution, and also have areas that are away from large population centres. You know, the UK, as beautiful as it is a difficult place to get to somewhere nice and dark.
And if people want to find out more about NORS or Loki, and they want to keep up to date with your findings and your expanding empire of Loki systems across the UK or the world, where can they go to find out more info about you?
Yeah, absolutely. So we've got a LinkedIn and a Twitter, NORS. So, you know, we'll be putting stuff out in there as we collect interesting stuff. So, yeah, keep posted.
Well, thanks very much for joining us, and my thanks to Dr. Laurence Blacketer for joining us to update us about that new project happening at Kielder Observatory. Keep posted indeed is the watchword, and keep an eye on what's happening at Kielder Observatory on our official website, kielderobservatory.org, where not only can you keep up to date with the latest news, you can also book tickets to our events, find out more about what the events entail, and you can also find out all the information you need before coming to visit us as well at Kielder kielderobservatory.org. We'll share regular images online as well on our social media channels, Facebook, Instagram and Twitter. Regular images shared there, and also news updates and the chance to grab some last-minute availability. If we have any cancellations, these will be shared on social media as well. So you never know. If you are in the area and you're free one evening, we could be seeing you sooner than you think. Don't forget to check out our previous episodes of the Kielder Observatory podcast. There's lots to check out. Much more information about the James Webb Telescope from someone involved in the project. Dr. Olivia Jones joined us in December to tell us more about that and what it's going to do to our lives and our view of the universe. And not long ago, we also spoke to Dr. Natalie Starkey, who talked to us about volcanoes in the solar system and how they're important for giving us an indication as to whether life might well be on a planet if we can find a volcano on it. All that and much more on any podcast channel. In fact, whatever one you're listening to this on, just search back for the previous episodes. And we'll join you in the next few weeks for another episode of the Kielder Observatory podcast. Until then, take care and we'll speak soon.